Hello. In this video, we will see about calibration and we will see seeing how to perform the testing and calibration as per ISO 17025. Our main focus in this video will be on ISO 17025 and how this particular standard, the ISO 17025, is used in testing and calibration of medical device. We will be going through the important parts of ISO 17025. When we will go on, we will also see some side-by-side examples of medical devices, how they are being used. So this is what it is all about. And the very important thing that we are supposed to know uh, is the difference between the earlier version and the current version. This ISO 17025 was introduced. There were different versions. The one which was very familiar was the ISO 17025 2005, the earlier version. Now we have ISO 17025 2017, the current version. So both the versions they rely on ISO 9001, whereas the older one it relied on 2000 variant, whereas the 2017 version it has taken a lot of inputs from the ISO 9001 2015, which is about quality management system. We must be aware of this ISO 9001, which is exclusively about maintaining the quality and the things related to it. So our ISO 17025 will also be focusing this. So if you are a hospital, or if you are a laboratory or a testing center or a calibration center, whoever you are, if you want to get an ABL certification, which is strongly in accordance with ISO 17025, then you have to make sure that you have this ISO 9001 already in your place. Or there are also some other options which we will see later. But it is always good to have ISO 9001. That way you can say that your institution has a well-defined quality management system. And then the another important thing is the risk management was not emphasized in 2005 version. Whereas in the recent one, that is 2017, it is completely, it is explicitly mentioned that risk management has to be taken care. When I say it's not emphasized, it does not mean that it is not at all there. It was there, but the emphasis was not given. Whereas in the current versions, there are emphasis on the explicit requirement of risk management. And then the document structure was perspective in the earlier version where they required certain kind of thing, whereas now it is flexible and it is completely outcome based, which means you can have your own formats, templates, as long as it satisfies the outcome that you have already defined. And the use of technology was limited in the earlier version, but now we have uh, we can like use any technology that we need as long as it does not affect the outcome of the system. And they also encourage, they recognize the use of tools, and they also encourage us. For example, earlier, if you want to give a delivery challan, any other such paperwork, it can be completely automated using software. There are a lot of softwares available. And the scope of activity is also a very important thing where a big change has happened. Earlier, this ISO 17025 was given only to traditional laboratories, but they have changed that thing also, that it not necessarily that it should be only the lab. This can also be done, or ISO 1705 17025 can be given to an entity which can perform the task on the site of the client, or it can also do remote work. Whichever is possible, whichever is acceptable, can be considered under the scope of activity. So you don't have to have a traditional laboratory. If you have a calibration testing and calibration lab on a van similar to what IIT Madras has, it is also acceptable. So that is one advantage in the recent version, so we can enjoy that. And these are the main three changes that I have noted down as we have discussed earlier. First one is the risk-based thinking is applied, and this also has a very big impact on reducing the prospective requirements and their replacement by performance-based requirements. Then there is a greater flexibility in the requirement for processes, procedures, documented information, and organizational responsibility. And they have also given a new definition for the term laboratory. So this is useful. So this will help us in bringing a broader entity into our picture. It will tell who we are as a laboratory. So this is the simple definition given by ISO 17025 about laboratory. Laboratory is any body that performs any of these following activities. It can be just testing or just calibration, but it cannot be just sampling. The sampling associated with any testing and calibration activity. So of these activities, if any combinations is being done in an entity, then you can consider that as a laboratory. So any laboratory would be considered as a standard laboratory if it has ISO 17025 certification, as long as testing and calibration plays a vital role in the laboratory. And this, in India, we do follow ISO 17025, but we get a certification as NABL, National Accreditation Board for Laboratories, who will come and verify whether we are following ISO 17025. And if they're satisfied that we are following ISO 17025, then they will give us NABL certification. So only with NABL certifications, the laboratories, can go to hospitals for testing and calibration. Especially if it is an NABH hospital, you should have an NABL certified laboratory to calibrate their equipment, to test their equipment. Now, this ISO 17025, what is the scope of this ISO 17025? It specifies the general requirement for competence, impartiality, and consistent operation of laboratories. So, what kind of laboratories? Any laboratories, as long as testing and calibration is considered, it is under the scope. And where does it apply? It applies to all the organizations performing laboratory activities. We know what is laboratory activities. These are the laboratory activities: testing, calibration, sampling, regardless of the number of personnel. So no matter how many personnel, there can be only one person who can act themselves as a quality manager, technical manager, a deputy engineer, and they can go and calibrate. However, that is not recommended, but that is also is possible. Right? And this scope will help in identifying, or will help in telling how your lab is set, what are all the output that can be taken from your lab. So this is quite important. And now coming to the terms and definitions, so these are all the things adapted from ISO 17025, the manual. There are certain important terms which we should be a little familiar with, so that we can work on ISO 17025 without any hindrance. So first is impartiality, which is very straightforward, simple thing. Presence of objectivity. Lab makes decisions based on facts and evidence. Any decision, any value you give, it should be completely based on facts and evidence. There should not be any manipulated values written on the result. So that is what they have mentioned. Objectivity means the conflict of interest do not exist and are resolved so as not to adversely influence the subsequent activities of the laboratory. If at all there is any conflict of interest, if someone feels that this SOP is to be changed, or this sequential order of conducting the experiment or performing the operation of a particular equipment is not proper, then it should be solved before starting the procedure itself. And other terms which convey the importance of the word impartiality include freedom from conflict of interest, freedom from bias. There should not be any bias. There should not be any prejudice. It should be completely neutral and fairness. So this is one important term. It is also the general requirement as per ISO 17025, which we will see a little later. And the next important terminology is compliant. We know what is compliant. Compliant is something that anyone should, treat it important, and we should take that, work on it, and give a solution for a better long-term satisfaction. And then there is inter-laboratory comparison. There is also something as intra-laboratory comparison. We will see that in the next slide. Inter-laboratory comparison is an organization that does a performance and evaluation of a measurement or test on the same or similar item, but two or more laboratories in accordance with predetermined conditions. For example, if you want to apply for ISO 17025, in India, if you want to apply for any real certification, you are supposed to produce an inter-laboratory comparison sheet to them. For example, our institution, our lab, Center for Biomedical Equipment Testing and Calibration in KPRIT, we have equipment, we do testing and calibration. Similarly, there would be some other entity, let's say named YETS. So this YETS and us, KPRIT, we should do um, a certain experiment in our lab as well as in its lab, and we have to show what is the result in both this lab. So that is the inter laboratory comparison. So if there is a permissible limit or error range, or what you can a tolerance level. If the tolerance level is more than a certain limit, it depends on equipment, and if that is beyond that limit, then there should be some other action to be taken, usually the calibration of the master equipment, right? So all these things comes under inter laboratory comparison. Moving forward, intra laboratory. So this is inter laboratory. The next one is intra laboratory comparison. In intra laboratory comparison, the organization, performance, and evaluation of measurements or tests on the same or similar items within the same laboratory in accordance with the predetermined conditions. There will be some predetermined conditions like this is how the lighting should be, this is how the temperature should be, this is how the humidity should be, like that. They set some predefined conditions. And other condition, what is happening if I measure some parameter. For example, if I want to measure the volume output of a ventilator, what is the value am I getting? What is the value I'm setting in my calibrating master device? What is the value I'm getting in the testing device? And I'll do the same thing once again. I'll do the same thing again. So when I do it in multiple iteration, I'll see how the results are, whether it is same or it is different. It should be usually same. Even if there are small changes, it is acceptable. So that is intra-laboratory comparison. So at this point, I would like to tell another important terminology which is not mentioned here. However, there is the analyzers, which are the equipment with which we perform testing, and the one on which testing is performed is called as utility under test or device under test. We usually write it as DUT or UUT. That depends. Now, decision rule. So, rule that describes how measurement uncertainty is accounted for when state in conformity with a specific requirement. So, this is very important thing. Uncertainty. Uncertainty. Every device, any device you take, whether it is a master calibrated equipment or whatever it is, any device will have some kind of uncertainty. There is no such device called as an ideally operating device. So, any device with uncertainty should have, I mean, any device will have uncertainty. So we should take some step to nullify this uncertainty. So that is what the decision rule is about. You'll have to work on it. There are a lot of formulas that varies with different equipment and analyzers. We will have one another video exclusively on uncertainty. When we calculate the uncertainty, there are different factors that influence uncertainty. After calculating the uncertainty, we will nullify it using different things. Right. So this is decision rule, and then proficiency testing. So evaluation of the participant performance, again pre-established criteria by means of interlaboratory comparisons. That is like I'm testing ventilator. I'm setting the value some x and y. What is the output I'm getting? If it is x and y, the device is fine. The same thing I have to do on someone else's laboratory, and I have to see how there it is performed. If in my case I'm getting x plus 0.5 and y plus 0.5, whereas in the other laboratory they get x plus 0.005 and y plus 0.005, then they have better results. So that does not mean ours is not performing well. That could mean that we need some other calibration that we have to check in the whether the given answer is in permissible limit. So NABL document, there are documents which says what are the limits and other things are available there in the document. We have to check it. Once the values are within the permissible values, then we are fine. If not, we'll have to do further calibration of the analyzers. We have to take it to there are certain national laboratories where they perform calibration of the calibrating equipment, right? And then there could be certain things which will not or which cannot be brought under this inter-laboratory comparisons. In that case, we'll have to do proficiency testing. There is an ISO exclusively for that, which is ISO 17023, where they have completed or done a proficiency testing and they will have a standard sheet. So we will compare our value against that standard sheet. Instead of comparing against another machine's output, we'll be comparing it against the standard sheet. So that ISO 17043. And then comes very important terminology, verification and validation. So when we say it very simply, verification is the thing right? You're getting an answer, you're verifying whether the answer that we have received is correct or not, whether it is right or not. I am measuring voltage, I'm getting the output in terms of resistance, then it is not acceptable. My intention is to measure a voltage, then we should get obviously voltage. If it is indirect measurement, then we use formula that is different. So that is one thing. So how this verification is to be taken care, how it is different from validation, what are the things to be done under validation, everything is again taken care by another ISO, which is ISO 17029. The recent one is 2019 variant, right? And validation is like, is the thing, I mean, is it the right thing for the purpose? For example, there is an example here on the screen itself. There are different procedure for measurement for different things. There's one measurement procedure ordinarily used for the measurement of mass concentration of nitrogen in water. I can use the same measurement or the same method to find the amount of mass concentration of nitrogen in human serum also. It's not going to make any big difference. Right? So this is validation. I'm validating my method, whether I'm using the right thing to do the test. So that is the difference between verification and validation. So these are all the terms and definitions of ISO 17025. Moving forward, we will have the general requirements of ISO 1025, which we will see in the next video in the part. Thank you.